evening, everyone. Thank you for joining us tonight on another webinar episode with Classpad.net. My name is Amy Chow, and I will be moderating tonight. For the sake of webinar quality, we're going to keep everyone muted and keep all videos turned off. So if you do have a question, if you will pop out that chat panel or open up the chat panel in Zoom, so that you can ask your questions there. And I will try to do my best to answer the questions as they come up. You can just type in the message there, and then everyone can see, your question as well. And if it's something that we really, a lot of people are asking, or I think it's a great question, I will stop Karen, who will be doing the webinar tonight for us, and have her answer the question out loud. So before we get started, I just wanted to introduce ourselves a little bit. I am the Training and Product Manager for Casio's Education Division, and my primary responsibilities are, coordinating these webinars, trainings, and workshops for schools and districts and at conferences, and also working with our development team on product updates and product development as well. And tonight we have Dr. Karen Greenhouse presenting for us, so I'll let her introduce herself.
Hello, I recognize most of the people on, so hi, it's nice to see you all again. And just real brief, you all can read my little blurb there. I am currently teaching at Drexel University, and I work with Casio. This is my 6th year. And I support their, technology development, Classpad.net. I've been a big part of that. So what I really want to say is I am a geometry teacher. And so I'm excited about this because geometry is my love. I've been doing that for 30 years. I teach a geometry course at Drexel. So tonight's focus is on geometry and specifically on transformations. And I kind of want to, let me actually switch screens here. Can everyone see that?
Yeah.
Okay, so we're going to be using Classpad.net, and if you are not familiar with it, it is a free web-based dynamic math technology. And here's the landing page. I really highly recommend, if you haven't created an account, that you do so at some point. It's free, and you can save all the activities I am sharing today. I'm going to send you links to them so you can play with them and save them and modify them to your heart's content if you have an account. If not, you can just start exploring. Now, you could play along with me. I am going to share a document that has links to some of the activities that I am doing. So if you wanted to play along, you could log on and start exploring and just sort of play along. Let me kind of explain how the evening's going to go. I'm going to start how I would with students. Just first, what is a transformation? Kind of very generic, just an understanding of the word and some of the descriptions that we use, like a translation is a slide. So where does that come from? And then I'm going to actually dive into showing you how to use the construction tools in Classpad.net. So I'm going to show you how to do the translations, how to do the reflections, how to do the rotations and the dilations. So we're going to do all of that. I'm going to show you how to do them. And then I'm probably going to run out of time, knowing me. I'm going to show you, I don't know if you can see my screen up here, but these are all the activities that I have created related to transformations that I'm going to share with you. So I'm going to send you a document. I'll put it in the chat panel at some point that has the links to every single one of these activities. So I'm not going to do all the activities. I'm simply going to walk you through because it shows off some of the neat features of Classpad.net, like hide show buttons and things like that. So we're going to get started. I'm going to dive in. I already have an account, so I've already logged in. So I'm into my account. This is what Classpad, if you've not played with Classpad before, this is what it looks like when you land. It's a blank screen. Click somewhere and you can pretty much do whatever you want. You could start calculating, graphing, and we're going to do geometry. And so I'm going to click, and this creates a geometry sticky, and I'm ready to go. Just a quick note, if you are playing along, and you just hit the start creating, you will not have this little cloud up here. And that little cloud is basically the indicator to show you you're in your account, because that means everything you're doing is auto-saving. If you're just playing as a guest, you don't have the auto-save feature. So that's a really nice kind of visual reminder to let you know you're in your account. So this is a geometry sticky, and you know, it has all the, if you've worked with Sketchpad or GeoGebra or any of those type of dynamic tools, this is a dynamic geometry tool. It has all the tools you would expect, so your point tool, your straight edge tools, vectors. We're going to be using a little bit of vectors here. Circles, arcs, polygons, rigid polygons, all these different things, and then all the things you can do, construction. So what we're going to focus on today is construction. So we're going to be constructing transformations. So when I worked with students, or when I work with my students now, and we think about what is a transformation, I always ask them to kind of define what the word transform means. So real quick, think about your students, or if you don't have students, if you've had students in the past, what would you think a student might respond? And in the chat panel, just real quick, what do you think a student might say if they were asked, what does the word transform mean? So I'm going to give everyone a second to type an answer. Okay, so I'm seeing a lot of change or a morph, and that is exactly what a transformation is. And so we want them to connect what their understanding of the word is to geometry, right? So a transformation in geometry is something is changing or morphing. I like the word-ish. So I'm going to get out a polygon. I'm going to put a polygon into my tool, and I'm going to use a rigid one for a reason. Rigid means once I construct it or draw it, it's not going to be able to change. So I'm using that for a reason. So I'm just going to make a relatively simple shape here using the rigid polygon tool. So notice what happens. I can't actually change its shape at all. I can move it. I'm pretty sure one of these makes, okay, it's this one. One of these lets me turn it. Okay. So this is a shape, right? So geometric construction, it's a shape, it's quadrilateral. And transformation means something's changed about it. So right now, this is how I used to always start with my students. I have this shape, and if I grab it and move it, what's happened to it? How would you describe that shape? What happened to the shape? Here it was, and then I moved it. How would you describe what happened to that shape? Again, in the chat panel. I'm just going to take the first couple answers. It shifted, okay. Translate, okay, so you're a student, you're a very advanced student. It changed.
We've got some
okay,
higher achieving students.
Really like the ones at the end there. It says it changed location. Yes, that is exactly what happened. It changed its location. It was up in the left corner, now it's down in the right corner. It slid, I love that, to a new position. That is exactly, that's the physical thing that happened to it. I slid it to a new position, and I can slide this shape lots of places, up, down, left, right, diagonal, but it is sliding. I'm changing its location. What didn't change in my transformation, in my movement of this? What didn't change? So I'm gonna bring a text sticky up here and kind of write things down. So we slid it, we changed its location. And so what didn't change was its size, right? It's still the same shape, it's just in a different location. That's what we call a rigid transformation. I changed it, but it stayed exactly the same, just in a new place. So its shape and its size stayed the same. So that's what we call a rigid transformation. It's something about it switched, but not its shape, not its size. So that's sort of how I start with students, trying to just get them to understand, what are you talking about when you say rigid transformations? I don't know about you, I learned geometry a really long time ago in high school, and we didn't have these words rigid and non-rigid. We used isometry. Anyone remember that? Raise your hand if you remember that. I don't know why they don't use isometry anymore. I guess it's too rigid says what it means, I guess. Maybe that's it. All right, so what we've just done is we've done a slide, like we split it. And I, at this point, might say a slide, the official math word for it, is a translation. So we're slide to a new position, right? And we'd go more into this. Obviously, I'm doing this really quick. So that's a slide. Now look at my shape. I'm going to do the same shape. And now I'm going to transform it a different way. What is happening now? What's happening now to my shape? It's not sliding anymore. How would you How might a student describe what they just saw happen? It rotated. Okay, and very good. Tom's being very specific. It's rotating around point A. So we're turning it. And most students, when you're, especially the younger they are, they're going to say, oh, it turned. That's sort of their, word that they're using. And that's, we want them to make that connection, but then we're going to introduce the official word, which is rotating, right? Rotation. So a rotation turns something. So different from a translation. Translation slid it and a rotation turned it. Whoops, is a turn. And what stayed the same in my rotation? There you go. Again, size and shape stayed the same. So this would be considered another rigid transformation. Now, I'm just going to throw this out there. I technically would like to be able to show you a really quick way to do reflection, like flip it over, but there is no way to do that just with this one shape. And I haven't found a tool that lets me do it unless I actually do a line of reflection. So I tend to not introduce reflection yet because I really just want to do some basics of just moving the one shape. I wish I could flip it, but I can't. So the next thing I do is this. So watch what's happening to the shape. So here's my original shape. And what all I'm doing, just so you know, is using the mouse, the little scroller on my mouse, to transform this shape. So what's happening to the shape now? The size is changing, right? So the size is changing. So sometimes it's bigger and sometimes it's smaller, expanding and contracting. Excellent. So that's called a dilation. So that is, I like the expanding and contracting, changing the size, right? Getting larger and smaller. So if we connect back to this translation and rotation, and then we look at dilation, would you say that a dilation is rigid? If we think about what we defined rigid to be, would you say a dilation is rigid? And if not, why not? So all of this is done before we get into an official, what is a translation? What is a rotation? What are all the properties? So would you say a dilation is rigid? Tom says no. Tom, why? I'm going to ask you why. The why is more. What makes it not be rigid? The size, right? Since we're changing the size, we've changed more than just its location. We've changed its size. It's not rigid anymore. It's not the same exact size and shape. So that makes it a non-rigid transformation. So this is how I would start, just kind of giving them just some basic understandings and ideas, kind of notice and wonder types of things, connecting to the words themselves. And then we get into actual constructions and looking at properties. So that's where I'm going to go next. And this is where I'm going to actually go through the different ways to construct the different transformations. So I'm going to start with translation first. So I'm going to pull up another geometry sticky here. And I like to make sure that the shape they draw, if you tell them to draw a triangle, I don't know if you've seen this, there's research on it. If you ask students to construct or draw a triangle, they almost, and not just students, everyone, they almost always make an equilateral triangle, or isosceles pretty close. So I tend to ask them to make a non-triangle polygon, so a quadrilateral or something. So get the polygon tool and just make a shape. And we do want the labels, and I'll show you why in a minute. I always make a flag, don't ask me why. Or a boomerang, I guess that's what that is. So to do a translation, there's actually two different ways. You can do a translation by coordinates, where you're telling it, so basically think translation rules, how far left or right and how far up and down, so you're giving it directions, or you can use a vector. So I'm going to show you both, and I'm also going to show you what I think is a pretty cool feature, is that you can use sliders to also do translation. So I'm going to kind of show you both, all three of those things. So here's this shape, has its points, and I'm going to select the shape. So to do it, I'm simply selecting the interior, and I'm going to go to my geometry tools. So now that I have something selected, I have a lot more tools available to me. And construction is where you're going to find your transformation. So when I hit construct, notice all these other things are, I don't know how to shade it out. I don't know how to define that. Here's the things that I can actually do based on what I've selected. So we want to do translation. So notice there's two possible ways to do translations. We can do it by a vector, or we can do it by coordinates. So I'm going to start with vector first. So when I click it, oops, my fault. I actually need to put a vector in there. So a vector is found in the straight edge tool, and it's this one over here. And, whoops, it's not that one. Sorry, I didn't actually select it. There we go. And we'll just make it, let's make it go like this. So if you've not done vector translations, the vector is giving you the direction that this shape's going to go in. So it's going to go in that direction. How long, the distance it's going to go in as well. So now I'm going to select my shape. I'm going to go to my construction tools, and I'm going to choose translate by vector. And why did it not? And then I had, oh, so notice up here, it says, it's kind of giving me little directions. Select the vector. I've already selected what I wanted to translate, so now it's telling me where's the vector. So here's my vector, and now it makes a copy. And what I love about this is, and this is why the labels are important, this image, so this is the pre-image, what I started with, and this is now the image translated by this vector. The image gets the prime, so it's showing you that this is a copy of the original. And it is because it's a copy or a translated image, it is controlled by the original. So you'll notice I can't actually move anything about the image here, the copy. But if I change the original, the copy will change exactly the same because it is a copy, a translated copy. So students, okay, they look at the vector and they say, oh, that's cool. What I like then is to discover things about this. So one nice thing is if I drag the vector, I can make a connection here. Oh, the distance between corresponding points A and A prime is the distance of the vector. I wonder if that's true for all of them. So I can test that out by just moving the vector and showing that the direction and the distance are connected to that vector. And I could measure the vector. So if I select the vector and measure, one thing I want to point out, those of you who are into more complicated math with vectors, you can actually measure their direction, which gives you the angle of the vector from a 0 point. So this is considered 347 degrees. And it also will let you measure the length. Oops, I want measurement. And so I could then just measure the distance between A and, let's just measure the distance between two corresponding points. So I chose those two. I'm going to measure their distance. What do I notice? Oh, isn't that interesting? Their distance is the same as the vector. And then you can now play around with the vector. You know, if I move the direction, everything seems to move with it. And it's always the distance of the vector and the direction of the vector. So that's vector translations. You could, let's see, where am I going? I'm going to open another window. It's going to be a lot of geometry windows just because I don't like to make a mess. So I'm going to do another polygon and show you. And it's always the same one. I wanted to show you that I could also translate by coordinates. And notice I don't have a coordinate grid on here. This is a geometry sticky. It does not default to a coordinate grid. So right now maybe coordinates don't make sense, but if you wanted to get into coordinates, you could add the grid. So you go up into the settings of geometry and you'll notice that there's lots of options here. I could turn on a grid and I could turn on the axes and I could turn on numbers. And so when I do that, now I will have a coordinate grid. And so it makes sense to now do coordinates, translation by coordinates. So I select it, same thing. I go to construct And this time I'm going to choose translation by coordinates. I'm going to do this 2 different ways just to show you. When students are learning about coordinate translations, they tend to get rules. And so the rule might look like, let me bring up a text sticky. It might be, oops, and it has 3 and -4, right? So that might be the rule. And they're learning what does that mean. So if that's the rule they're being asked to translate by these coordinates, when they come here and do coordinate rules, if I put in those, why isn't it letting me? Uh-oh. All right, I'm going to delete that and start over. All right, translate by coordinates. All right, so it's going to ask me, what's your rule? And so with students, just put the rule in, and the idea is for them to figure out what's actually happening. And so then when we go down to y, we're going to put in -4. And what happens to the shape? Well, its new image has been moved, right? Well, how does that connect to this rule? And what you want to do is measure the coordinates of some corresponding points. I'm just going to pick 2 corresponding points here. And these are not very nice. I should probably snap them. Let me do that. A nice thing in geometry when you have grids, especially when you're working with students that are, just learning things, you tend to not like to use the decimal coordinates. So one nice feature you can turn on is this snap. And if you snap, it will automatically go to a, not automatically, as you move it, it'll only move onto grids. Or you can do fix where it can't even move off a perfect grid. And I think I'm going to also turn on a minor grid. So watch what happens. So now, because I turned on that fixed snap, watch what happens if I move. I have to move the original, remember. Why isn't it letting me move it? So notice now it's going to nice numbers. Even though they might be decimals, they're nice numbers that I can easily make the connection. And let's actually put it, let's make that one. All right, so the connection that we want to see is, okay, so C, the original, was at -1, and C, the translated, is at +2. How does that connect to this X rule, right? So if I add -1 plus the rule 3, I end up with a +2. So that's sort of the connection we're trying to make them see. And so you would do several of these, obviously. So that's the other way to do translations, is by using actual coordinate rules. But you don't have to use a very specific rule. You can use sliders. And this is a feature I really like. So I'm going to change this. And a slider is simply based on a variable. So I'm going to just call this A. Instead of giving it a specific number, I'm going to call it A. And instead of giving the Y, I'm going to call it B. And what happens is I now have sliders that control the movement. And I can change, these are sliders. So this, what's the A going to do? Well, it's the X. So it's going to change the X movement. So X is left or right. And B is the Y coordinate. So it's the up and down. So it's going to let me move my shape left, right, up, down, and kind of, again, make that connection. And I can change the parameters here if I want. Sliders are pretty flexible, so I could make it not be, like if you look at my grid, it's only going to 6, so maybe I just want to only stay within my grid. And this is nice because then you can ask interesting questions such as, what values, I'm going to ask you this before I actually do this, what values of A and B would make the current image land on top of the original? And let's actually make the, I'm going to change the color of this one a little bit. So am I getting any answers? No, no one's answering me.
Everyone's
If I want
thinking.
the image to land, if I want the red image, the image of my original, to be exactly on top of the original, so be exactly the same, what values of A and B do I need? Anyone? No one? All right, I'll tell you. I've got A is -1, okay. Let's see, and B is -1. Well, that didn't work. So think about this. If I want the image to be exactly the same as the original, I basically don't want it to be moved at all, right? So I really need to have my value of A at, why can't I? Oh, because I'm sorry. This is my fault for not allowing it to step other than, let's see, it should be at 0, if I'm correct. And it's not letting me do exactly 0 for whatever reason. Why is it? That is annoying. There we go. If it's at 0, that means I haven't moved it, right? I haven't really translated. I didn't give it a rule. So these are the kinds of things you're hoping students understand, is that that rule is telling you what to add or subtract to, or multiply, because you can do a scalar, but if you do a scalar, then you're working with dilation. But what to add or subtract to move that object. So now you could say, okay, what if I want, so right now my original is in quadrant 2. So what if I want the image to be translated and so that it ends up in quadrant 4? How would I have to move? What possible values for A and B would work? So this is where they're really kind of testing their understanding of translations. So I'm not going to keep going, but I'm just giving you ideas. So you can do translations by vector. You can do them by actual specific numbers, coordinates, or you can use sliders, which allows you a lot of flexibility and some great questions to help students explore and test out their conjectures, types of things. So I love the sliders. They're sort of my favorite thing. So let's move into another geometry sticky here. Let's move into reflections. So reflections are really nice. And again, you always have to start with a shape, and I'm going to try to make it not be the same shape that I keep drawing there. And you need something to, a line of reflection. So it could be a line, it could be a segment. Classpad will not allow you to reflect over a point. I believe Sketchpad used to, but it has to be part of a line. So it could be an array, it could be a segment, it could be a line. I tend to use a line when I first start. That's the line one. So I'm just, and you can make your line kind of be anywhere. And so same thing as the translation. You're going to select what you want to reflect first, or actually let's do the reverse. You can actually go into construct and choose your transformation. So we want a reflection, and look at the directions up here. So it always gives you little directions based on what you haven't done yet. So first thing it says, well, you don't have anything that says selected, so select some objects. And notice it has this little okay here. That means, are you done? So I could select more things, but I'm done. So I'm going to say, yes, I'm done. Okay. Now it says select the line you want to reflect over. So it could be a segment that's in the shape itself. So then the shape reflects over itself, but I'm going to use this outside line here. And so now you talk about what do you notice when you reflect an object? What is the same? Well, we already kind of alluded to that before. What is the same? I'm changing the color of this because I like them to look different. In the orange one, what's the same in the orange as in the blue, the original? So here's my image, here's my pre-image. What's the same, or what appears to be the same? I'm keeping you guys on your toes. Okay, so it is a rigid, it's another example of a rigid transformation. It It is the same shape and size, and here's where you could have them measure just to verify that their conjecture is true. Like, so they could measure AB and confirm that that's the same as A prime, B prime. We're not going to do that just because we're trying to get through a lot of things. And the nice thing is now you can actually start exploring some interesting features, right? So you can move the line when it's, is there any time, why can't I put this image on top of its pre-image? What is different about this? Size and shape are still the same, but what is different? And this is an interesting thing that happens with a reflection. The orientation. So this one changes orientation. So kids have a hard time understanding orientation, so I always think clockwise, counterclockwise. So if I were to say the alphabet here in my original, A, B, C, D, the direction I'm going in is clockwise. But if I went and did the same thing with my image, A prime, B prime, I'm actually going counterclockwise. So orientation is basically sort of the directions, clockwise, counterclockwise, that you're going in. And what we'd want students to discover here is, and this is where it's nice to have, I'm going to connect my corresponding points, and hopefully the connections you kind of want to be making here with reflections is, wow, this appears that each one of these segments connecting my corresponding points seems to be crossed by that perpendicular exactly in the middle. And how could we verify that? Well, we could measure the distance from A prime to the perpendicular and A to the A prime. And that what they find out is that a reflection line is the perpendicular bisector of the segments that connect corresponding points. So there's lots and lots of things you can discover very quickly. And just like with translation, I could do a rotation, and a reflection with a slider instead. And I really, again, love the sliders because you can ask some great questions. So let's just I'm going to break my rule and just do a triangle because it's faster. See, that looks pretty, maybe isosceles. All right, so I'm gonna show you that just like with translation, you can do a reflection with, no, you can't. Sorry, you can't. That's the one that you can't because it doesn't make sense to do it with a slider. Sorry, I'm getting ahead of myself here. I'm looking at my time, so all of a sudden I'm going really fast. I knew I have too much plan. I want to make sure I show you how to do each one of the different transformations before I kind of explore these activities up here real quick. So real quick, we're going to get into a rotation. Rotation you can do with a slider, so maybe I'll do that first. So here's my rotation. And for a rotation, you do have to have a point to rotate around. So it's a point. So you can either put a point not on the object somewhere or use a point within your object, but you do have to have a point that you've decided is going to be your point of rotation. So I'm going to put that point there. I'm going to, just like the other ones, you select your object, you can go to your construct tool and you can do rotate, and it's telling me up here, select a point. So it could be a point in the object itself. I'm using this outside one. And here's where rotation is going to ask you for a specific angle. And that's very nice, especially if you're working with coordinates. But I'm going to just show you real quick a slider because I like the slider. No, we don't want to use A. We already used that. So here's the slider. So notice the slider's going from 1 to 360. I really kind of want it to go to 0. You could even have it do negative. So you can change these. So I'm just going to leave it there. And I want it to step by whole angles. And let's change the color. I like to change the color, if I'm working with students in particular, I like to change the color of the translated image because then it helps students kind of really keep track of it. Oops, I changed both of them. Let's change that back to blue. It just helps students kind of keep track of which one was the original and which one is the transformed one, the one that was the image. So here's my rotation. It's moved around this point, and then what you want them to do, if you can add a grid on here and they can make a connection of the types of angles. So this is 90, Let's make it 90. And here's where students need to start making connections. So again, always connecting the corresponding points to the object that they have been transformed around. So we've transformed around this point D. So I'm going to connect A to D, and I'm also going to connect A prime to D. And this is where we want them to notice that the rotation that's currently here, this rotation angle 90, if I measure this angle between my corresponding points, oops, I have too much selected. There we go. Actually, I'm going to do that one. It's also 90, and that's the connect. So you could do that with all of them. And as I change the slider, what happens? Well, my shape moves, my angle changes, and my angle between the corresponding vertices is matching the rotation angle. And you could add in, you know, there's lots of things we can discover, and that's what the activities I'm sharing are doing. But you could add in a circle here and show that it basically all the corresponding vertices are connected by concentric circles. So there's so many interesting things that you can discover by just exploring this. But I like the slider because then you can say, okay, what angle are they, especially if you're on a grid, are they in two opposite, exactly opposite coordinate, what am I saying? Somebody help me. Amy, what is quadrants? Thank you. There. I knew what I was trying to say.
You're welcome.
Thank you so much, Amy. That was so helpful. When are they the same? What angle would they be the same? Those types of things. So you can do a specific angle measure if you're really, you know, up here, or you can use the slider. Last one is dilation, and then I'm going to spend the little bit of time that I would have left just kind of showing you all these different activities, and I'm going to share the worksheet or the paper that I have with you that has all the links to all the activities. And you can use that, and I'll also send it in a follow-up email too, so don't worry if you don't get it tonight. But the last one is a dilation. So this is the one that is the non-rigid. And just like with the translation and the rotation, you can do dilations with specific scale factors, or you can use a slider. So I'll show you both. So let's just make and actually let's start in a different place because boy, it's getting boring. Now a dilation, you need a point of dilation. So again, it could be within the shape, which means your dilated image is going to kind of stay connected to itself, or it could be outside of the shape. I tend to like the outside, but you know, that's your, and all that means is if you dilate, it's going towards that point or away, depending on what scale. So if it's getting smaller, it's going to go towards that point, and if it's getting larger, it's going to go away from that point. So that's what this point of dilation is controlling. So as with the others, you can go to your construct tool, choose the transformation you want. So this time we want dilation. It's going to tell us up here, what do I want you to do? I want you to select something to dilate. So here's the thing I want. Okay, I'm done. Now select the point of dilation. And now it's asking me for a scale. Do you want it to be larger, smaller, or do you want to use a slider? So let's see what it looks like if I just use a number. So let's do 0.2. So we're going to make it smaller. And you end up, ooh, very, very small there.
Tiny.
It's very tiny. I made it maybe too small. And here's where measurement is important. This is all about proportionals, right? So we want to measure the sides and compare them and see that all the sides have the same ratio, the ratio of the scale, or 0.2. I would want to measure the angles and show that the angles are the same. So there's lots of things that they would then discover about this, and you'll see that that's already done for you in some of the activities I'm going to be sharing. And now let's just look at one that's bigger. So let's do 2, and that's going to go off the screen because of where my point of dilation is. So you see, you can't even see it. So if I move my point of dilation and move my image, there we go. So now that's twice as big. So these are the things you want them to notice. And again, what's the ratio of the sides, and what's the ratio of the distance of this vertex to the point of dilation and this vertex to the point of dilation. It's all connected, and these are the things that then they can use the dynamic geometry for. Let me show you what it looks like if you have a slider. So instead of a number, I'm just going to replace it with a variable, and I think I can use D for dilation. So now I have a slider, and notice it is at 1, and what do you notice right away? When the dilation is 1, the image is the same as the original, right? Because 1 times all the lengths, the proportion is the same. So that's something we've discovered. And notice this, I like negative because negative causes interesting things to happen. So it is important to see negative. And so these are just representing the scale factor. And you could make the steps be decimals, or I'm going to just do 1 step by 1 right now just so we can do it. But I want to show you what happens when you go to negative. Well, what happens when it goes to 0? What happened to my image? Where is it? I see the points, but where'd the image go? My scale factor is 0. So I dilated by a scale factor of 0. Right, I basically made it be a point down to nothing, right? Because the ratios are all 0. What happens, and let's just make a conjecture, what happens if I make the scale factor negative? What's going to happen? What's the image going to look like? The dilated image. Make a conjecture, make a guess before we move. And this is the nice thing about sliders. This is why I like to use sliders for transformations, because it lets you make a conjecture, lets the students guess, and then test it out and see if they were right, and then verify those types of things. Okay, so I have rotate 180 degrees. All right, that's good. So that means it's going to turn, right? Flip a little bit. So let's see if that's true. So I'm going to make it be a -1, which means it'll be the same size as the original, but because it's negative, it won't be the original. What will it look like? It's the same size, but it is, well, let's see, where's A? It is rotated 180 degrees. Good conjecture, Tom. So sliders, again, are an option for everything except reflections, because it doesn't make sense for reflections. So the last part of today, and I'm going to, hopefully this works, I'm going to throw this in the chat panel. I think that's how I do it. I basically created a, how do I do this, Amy? Oh, I see. Never mind.
You have file option there.
I see it. There it is. All right, so I share, it's just a PDF, and basically there are 2 activities that I created for each type of transformation, and then there are 2 activities that are sort of applications, because one of the things students have to do on standardized tests and stuff is they're given 2 images, so maybe they were given these 2 images, and this point might be hidden. And you can hide points, by the way, in Classpad by clicking on the, or you can hide anything in Classpad if you select it and go to visible and hide the object. So maybe they're given this on the test, and they say, okay, A prime, B prime, C prime is a dilation. Find the point of dilation. So they are given problems like that, and it's basically, can you apply the properties that you learned about dilations to figure out where that point of dilation had to have been? So the last 2 activities that I've shared in this document are types of problems like that, so application problems. So I think I have, what, 15 minutes left? So I wanted to just kind of basically show you each activity. So this is a lot of activities. We're not going to really do anything because I wanted to show you some of the neat features that Classpad allows, like the hiding and the showing buttons that are created. So this is the first activity. It's sort of an introduction to translation. So you'll notice I have sliders and I have a bunny. And the bunny's eye is sort of our point that we're looking at, even though the bunny's moving. And so the idea is, you know, what's happening when you move V? Well, the bunny is moving, and you're looking at where the eye is. The bunny, I moved V to +2, and the eye went up 2. So maybe V controls up and down. And so they're exploring basically translation rules. So this is a whole activity on translation with coordinate rules. So first they're just kind of exploring and noticing and wondering simply by moving this bunny and kind of paying attention to its eyes. And then, and there's places you'll see, so this is an example of a pre-made ClassPad activity where there's directions in the text, and there's places for students to write their answers, there's activities for them to do. And then we get a little bit more specific here, and now we have an image. AB is the image, and the idea is to figure out, I'm trying to remember what I did. So basically they're asked, can you make CD lie on top of AB? So like it's, can you apply your rules? Like how would you make this segment here, which is a translation of this one, how could you move the slider so that it lands on top of it? So it's kind of helping them connect the idea that, well, I need to get these coordinates, C, all the way back to A. How am I going to do that? Well, I need to subtract or whatever it might be. So that's helping them connect there. So that's where we're going at this. And then they expand the same thing and explore more with like an actual shape, not just a segment. So that's the first one. It's kind of just exploring coordinates. The second activity is looking at translations and vectors. So trying to make that connection. And so they're first supposed to notice, and then they can move the vector around and make some notifications there. And then these are the hide show. So in the geometry sticky, it is possible to create, measurements and shapes that you can pull up later. So these were created and then hidden, and I'll just quickly kind of show you where that is for those of you interested. Well, I think I have to select something first. If I select something and say I want to hide it until I need it, and I'm not going to do it, but I'm just showing you how the process. I selected these two, and this word right here, group, when I hit group, it creates a little hide show button that I can change the name of, and then I can bring it back. So let me show you what that means. So I have already measured the sides and the angles and the distance because I want students to focus on looking at the properties. I don't want them to get bogged down in the measurement. So if I click this, here's the measurement of the sides. And so what is one thing? There's just, okay, look at the measurements. What do you notice? Change them. Change, where's the original? Change the original. What do you notice? Well, the sides change the same. So that's one thing we've noticed. We could hide it and put them away. Look at the angles. What do you notice? And so all that measurement's already done, and they can just start making their own, looking at patterns, looking at things that are the same, and then the distance. And what are they supposed to notice here? Well, they're supposed to notice that the distance between corresponding points, it happens to be exactly the same as this vector. And if I change the vector, all the distances change. So that's the beauty of hide show. So there's a lot of the activities that are shared that have these hide show buttons so that students can get to the discovery and not get lost in the having to do it themselves. So that's what you'll notice here too. Reflection, you'll notice they're all kind of very similar. So this is, I've already done the reflection. They can move things, they can change things, all dynamic. And then there's hide show that allow them to look at the segments, look at the measures, look at the reflection angle. This is where they're, all right, why isn't it working? I think I've gone too fast and have frozen myself. Or maybe I have too much open. I have a lot open. All right, here we go.
There you go.
What they're supposed to notice here is that this is, we want them to figure out that, the reflection line is the perpendicular bisector of the segments that connect corresponding vertices. I mean, that's one of the properties of reflection, right? So that's where this is going with the hide show. So again, all of these activities have the measurements and stuff done so that students can really just spend their time moving and exploring and doing things like discovering the patterns that we want them to figure out. So same thing here. This is all about coordinate reflection. So it's already done. So what happens if I reflect this over the x-axis? And so notice the coordinates are measured. And if I go over the x-axis, we want them to figure out, wow, what's changed. So it looks like they have the same numerical values, but the y coordinates are their inverse, their additive inverse. And that's what we want them to notice. And the cool thing is they can do this a million times. I can change this shape. I could move this shape somewhere and do it again. And it's still there. So this becomes almost a nice kind of personal assessment. They can change it, test their conjecture, and then look at the answer and see if they've got it. So some of these activities are like that as well. So there's lots of this. Oops, I have these turned on. They should all be off. Again, I'm going really fast, so I'm just going to go through this. So you'll notice they're all very similar. I've done all the behind the scenes work, and I want them basically exploring and noticing and writing their observations and making conjectures. That's where we're going with all of this. So all of these are activities where I'm using the hide show, I'm using sliders, I'm asking questions, and letting students do the discovery. And the nice thing is, because these are already done, you can, in a sense, use them as an assessment and change it to different locations and still do the same activity over and over again. And same thing here with dilations, same type of thing. And I wanted to get to these last ones. Okay, so these are sort of assessments, if you think about it. And the idea is, here's your pre-image, and this is something's been done to it, and they have to figure out what kind of transformation. This is a very typical type of assessment. So hopefully now they have an understanding of properties, and so they could look at this, okay, A, B, C in the reverse order. So maybe it's a reflection, because I know that reflections change the orientation, and they can, I don't know why when they click the answer, it shows the answer, but it's not doing it now because it's being stubborn. There we go. And it actually shows them where the line of reflection is. And this was actually two things that were done. So this is that type of activity. You've got to try to figure out what combination of transformations might have been done to this shape to get it where it is, and then you can test it out and things like that. And they can actually try, they know, oh, I know this had to be a reflection because the orientation switched, but if I just do a single reflection, I don't land on this, so maybe I had to do something else. So that's where they're going. So you'll see there's several different things. So this one's obviously a dilation, but it also seems to have slid. So maybe it's also a translation. So there's lots of different activities. And then this last one is where they actually have to figure out the rules, or use the rules and move the shape to where it should be, and then test if they got it right. So if I want to follow this rule, I'm going to move the triangle where I think it should be, and I'm totally not doing this right. And then I'm going to see if I got it right. I'm pretty sure I got this one wrong. Yeah, I totally got this wrong because I didn't try. But that's what they're doing, is testing themselves to see if they can do it. So that's one way. And then down here, they actually have to move them to the right place. And then there's one, I'm trying to find the one I really like. There's one where they have to find the center of rotation, all those things. So the last two activities that are on that worksheet are really kind of assessment type activities after they've learned all the properties. And wow, 5 minutes left for questions if there are any. I know this is a lot of stuff.
That was a lot
today.
of information, but
There's
it was a lot of
stuff, like crazy busy.
Yeah, but a lot of great information, a lot of cool stuff that you can do on Classpad.net. That just using it as a basic tool you may not necessarily know.
There are, in fact, let me pull that up. There we go. We have a YouTube channel, and
yes,
there is in fact, on that worksheet, on the sheet that I've sent you, the very bottom, I gave you links to sign up for a free account, because the nice thing about these activities, when you open them just from the link, they're going to be in guest mode. If you have an account, if you open it if you go to your account, you can save them and put them into your own account and then modify them. If you don't like the questions that I came up with, or you want to add something, that's the beauty of having an account. You can modify anything that's already created. And I put the YouTube support on that worksheet as well, and I put the geometry playlist specifically because I do have how-tos on all the, I think I have them on all the transformations at this point. So if I went too fast, which I know I did, they're there. And this webinar will also be recorded. So
yeah.
Oh, so Tom is asking, can you designate any line on the coordinate plane as a line of reflection, such as, sure. The answer is yes. So let me see if I can get back to where I wanted to be. New paper. Yes, I want a new paper. So I'm basically wiping the slate clean. No, I guess maybe I'm not. All right, let's go back to my other paper here. All right, so Tom, to do that, so in geometry, if you want to actually, so I'm going to turn on my grid just because. If you want to actually enter, you can enter expressions on the grid.
Right.
And to do that, I always forget exactly where it is. There it is.
There it is, yeah.
I don't know why it's there, but you can, if I click this, I can enter the equation. So you have y equals, I'm just using the one you gave me,
2x plus 1. Yeah.
And so it graphs that. So now if I had a shape, I could now use that line because it is now just a object in my geometry, and I could reflect over that. So the answer is, did I do it wrong? Reflection, select a line. All right, I don't know why it's not letting me do it. You should be able to do it. I don't know why it's not letting me.
You think it's not recognizing that it's actually a line? It's an object now.
Interesting. Well, maybe I'm wrong. I'll have to go test that because you should be able to use it because it is an object because I can move it. Well, maybe I can't move it. All right, I was wrong. Oh, maybe it has to be an expression. No, that doesn't make any sense. Okay, we're done with the webinar, by the way. I'm just now intrigued.
Yeah, are there any other questions?
Oh no, that's not it.
Yeah, that wouldn't be it either.
Any other questions? You should be able to do this, Tom, but apparently.
Well, Karen will definitely explore.
I will figure that out. I will ask our R&D people.
Yeah, because that would definitely be a neat feature to add if it's not possible yet. Yeah.
I thought it was, so what do I know? So anyway, thank you so much, everybody. Really appreciate you hanging in there and answering my questions. I know it was a lot.
Karen, if you will go back to the PowerPoint. Yeah. And just as she mentioned, we have a YouTube site that has all of this, that will have this webinar up tomorrow, hopefully, and has all our previous webinars, and we'll have all our future webinars uploaded so that you can watch all of those as well. Follow us on social media just to keep up to date on all our webinars. We will post, every week just to let you guys know how to go register and, what the topics are. So check that out on Facebook, Twitter, or Instagram. And if there are no more other questions, thank you guys all for joining us tonight, and have a good rest of your week.
And what is next week's webinar? Isn't it
next week?
Linear something? I've never figured it out. But anyway, thanks so much. Have a great night.
Yes. Next week is inequalities.
Really fast. So good night, everyone.
Good night.